Yeah, good evening, everyone. So before I start, can anyone please confirm whether my voice is clear, whether my screen is visible or not, right?
Yes, I was being usable or was also clear.
Thank you. Yes. So myself, I'm Vijay. I hold like 14 plus years of experience, which includes 7 plus years of experience in Hadoop and Spark environment. So as part of today's demo, just I'm going to cover the following part, right? So what is big data? So already we have got many technologies. Why again Hadoop required? Why Hadoop? Okay. Drawbacks what we see with the current databases, drawbacks of databases, right? Current databases. Hadoop advantages. Next is like Hadoop components, right? Hadoop components. And job market. Hadoop job market. I'm going to discuss these things, right? Fine. Fine. What is big data? Why Hadoop? Drawbacks of databases, Hadoop advantages, Hadoop components, and Hadoop job market, right? Okay. First, what is big data? So the name itself saying, right, huge volumes of data. Big data like huge volumes of data. How the data is getting stored currently? What are the data storage units, right? Like KBs of data, MBs of data, GBs, gigabytes, terabytes, petabytes, exabytes, zettabytes, petabytes, sotabytes, so on, right? From TB onwards, we say it as big data, huge data, right? So you should have seen like KBs of data, MBs of data, GBs of data, or even TBs of data. But do you think like petabytes or exabytes of data, is it getting generated in the current real world? If so, examples of petabytes of data generations, petabytes of data generation. I want the sessions to be interactive, right? So can anyone say like petabytes of data generation, examples for petabytes of data generation? If I take example of this banking sector like SBI, right? If you take an SBI, or if you take any bank like HDFC, right? Within the city, you see hundreds of branches for this particular bank, right? Within the entire state, you see thousands of branches. Within the entire country, lakhs of branches, right? Again, within the each branch, we see like millions of customers. Each customer making multiple transactions per day, per week, per month, per year. Each and every transaction need to be stored, right? So we see like huge data getting generated. Okay, forget about this banking sector. You are aware about like social media like Facebook, right? Facebook, it has got users throughout the world, not only within the country. It has got users throughout the world, millions and trillions of users for Facebook, right? In a minute, how many posts are getting circulated? What should be the storage capacity of Facebook? Each and every post and video need to be stored, right? So what is the data generated by Facebook in a minute? What is the data generated by Facebook in a minute? It won't be like MBs or GBs, right? It will be in TBs or petabytes of data. Not only like Facebook, like today, if you observe, any application, if we talk about any application, right, it is generating huge data. If I talk like 1 minute transaction, if I talk about 1 minute transaction only, right? In a minute, how many FB posts, Facebook post, right? What is the data generated by Facebook in a minute? What is the data generated by Twitter, by the Twitter tweets, right? Huge data, right? And if you talk about like everyone querying in the Google, right? Google, what is the data generated by Google in a minute? And everyone creating your own videos and uploading in the YouTube, right? YouTube videos upload, YouTube videos upload. What should be the storage capacity of this? And like millions and trillions of users using email or Gmail messages, right? Email messages. Okay. Each and every message need to be stored. What should be the storage capacity for this? And if I talk about the bank transaction, just now I was talking like within the entire country, we see lakhs of branches. In each branch, like millions of customers making multiple transactions. Now here, like telecom transactions. And if you talk about like e-commerce websites like Amazon, Flipkart, e-commerce website like Amazon, Flipkart, for all this, right? Huge data getting generated, right? So everywhere you can see like huge data is getting generated. So not in GBs, data generated in petabytes. Okay. So for storing this huge data and processing this huge data, we need to have some proper storage systems. Day by day, as this data is increasing enormously, we need to have some proper storage and processing systems, right? Okay. So for storing this huge data in petabytes, right? In petabytes of data. So as a solution to all the storage level problems and processing level problems, we have got a framework called Hadoop for storing unlimited data storage. Later I'll come back to this Hadoop. But if I say like we have got some databases, for storing data, right? Currently, we have got some databases. Like if I talk about this database like Oracle, like MySQL, SQL Server, right? So these are used for day-to-day activities, right? Like the day-to-day operations. Oracle, MySQL, SQL Server for day-to-day operations. Or OLTP, online transactional processing. OLTP for online transactional processing, day-to-day operations, right? But we have got some specialized databases. We have got some specialized databases like Teradata, Netija, Vertica. These database, specialized databases, they are used for data warehouse purposes, OLAP, right? They can handle data up to some extent, right? But for huge data, for unlimited data, right? For unlimited data storage, we go for frameworks like Hadoop, where it can accommodate unlimited data or huge data. So later I come back why these databases, such specialized databases, cannot support unlimited or huge data like Hadoop. Okay, what is the limitations with this databases, right? But before this, let me just discuss about the generation, like how the data generation, right? How the data is getting generated and what are the sources of the data and what are the types of data from where this data is getting generated. If you observe, right? Observe. This is your data. This is the data which got generated. This is the data in the entire real world, right? This is the data in the entire real world. It got generated from 1971, from the last 50 years, 1971 to 2021, right? If you talk like nearly like 80% of the data, whatever we see in the current world, right? It has got generated from the last 10 to 15 years, right? It has got generated from last 10 to 15 years. And if you talk about the previous 40 years, right, only we see 20% of the data which is generated, right? The reasons why huge data getting generated, the reasons why huge data is getting generated, especially from the last 10 years. What are the reasons for it? The reasons why, okay. Because of usage of technology, because of usage of technology, because of usage of smartphones, because of usage of internet. So because of the usage of this technology, smartphones and internet, right? Today, if you see everything through online banking, online shopping, online education, right? Online communication, audio, video, chatting, right? Okay. So we see that the huge data getting generated from the last 10 years because of this. Okay. Now, from what are the sources from where this data is getting generated? What are the main sources from where this data is getting generated means? Mainly, I can see three sources from where this data is getting generated. Mainly three sources, like social data, machine data, and third is like transactional data. These are the mainly three sources from where this data is getting generated. Social data, nothing but data which got generated from social websites like Facebook, Twitter, all this, right? And machine data, the name itself saying the data which got generated from this machines means whenever, for example, whenever you go to a shopping mall, right, for the items you purchase, a bill is generated, right? Means the data which got generated by reading or scanning the barcodes, RFID chips, all this such kind of data we call it as machine data. And transactional data for day-to-day operations like bank transactions, telecom transactions, all this, right? Okay. So mainly three sources from where this data is getting generated. And if we talk like the data, the huge data which is getting generated currently, it's mainly going to take three formats, three types, right? Three types. One is a structured data. One is semi-structured data, semi-structured. And third is like unstructured. It's like structured data, semi-structured data, and unstructured data. Mainly it is going to occupy three types. Structured data means data which is fully organized in the form of rows and columns, right? Which is in the form of rows and columns, like Excel sheets. Database tables, right? Database tables. And if you see like semi-structured, like JSON, XML, etc. Semi-structured means which are not fully structured, which are not fully unstructured, like XML files, JSON files, right? Key value notation. Unstructured means like short messages, articles, images, videos, all this, right? Images, videos. Okay. So three types: structured, semi-structured, unstructured. Like today, like if we talk like that huge data which is getting generated mostly is going to occupy unstructured format. So the biggest challenge is to storing and processing this kind of data like unstructured data. So as a solution to all the storage level and processing level problems, right, we have got a framework called Hadoop. We have got a framework called Hadoop, right? Okay. Hadoop is mainly for two things, right? Hadoop providing mainly two services. Is mainly for two things like storage and processing. Hadoop is meant for storing and processing. Okay, for storing in generally, if you talk about any technology, right? C or C++ or Java or .NET, all this, they are for processing. Databases like Oracle, databases like MySQL, SQL Server, right? These are used for storage. So either they are performing either storage or processing, but Hadoop is a kind of technology which performs both storage and processing. Okay. So when Hadoop is able to accommodate huge data, unlimited data, and can process that huge data, do you think like these technologies, storage and processing technologies, will go away from the market? No. So you need to know like when Hadoop is required, right? For one record or two records, Hadoop is not required. For a single transaction, Hadoop is for millions and trillions of records, right? For batch processing, Hadoop is for batch processing or for batch applications, right? So for millions and trillions of, okay. So for storage, does Hadoop use any database internally? Does Hadoop use any database for storing its data? No. Hadoop doesn't use any database, but it is using a special kind of file system like Hadoop distributed file system, right? Okay, it doesn't use any database, but it goes with a special kind of file system called Hadoop distributed file system. For processing, right? Either we can go with like MapReduce, Spark. So these are the services of Hadoop storage and processing. Unlimited data, huge data can be stored. Okay. Now observe. Now I'll come. Okay, hope you understood it. Why Hadoop required for storing and processing, and drawbacks with the databases. Right? Drawbacks with the databases. You may ask why. What are the drawbacks we see in databases? While like okay. Now let me just brief you about one by one the drawback. Right? Why databases like Oracle is not chosen for storing the Hadoop data? Right? First one, very limited storage. And in most of the databases, no parallel processing, right? No parallel processing, right? Okay. Drawbacks with databases, low limited storage, no most of the databases, no parallel processing. And see the next one. If volume increasing, right? Volume increasing, speed decreases. If volume increases, speed decreases, right? Speed. limited storage, no parallel processing, volume increases, speed decreases. So to justify this as volume increases, speed decreases, just observe this queries, right? Select sum of amount from sales one, right? Think that it has got, okay, sales one. Next, one more query, select sum of amount. Select sum of amount. Select sum of amount from sales one, select sum of amount from sales two, select the sum of amount from sales three. Assume that you have got some different records in each of this. Think that in sales one you got some 10 records. In sales two you got, think that you got some 1 lakh records. In sales three, think that you got 1 crore records, right? 1 second. Okay. Now, which query is going to execute faster among these three? Total amount from 10 records, or total amount from 1 lakh records, or total amount from 1 crore records? Which query is going to execute faster among these three queries? Obviously the first query, right? Because total amount of only 10 records. Means as query to query volume increasing, speed decreasing, right? Complexity, if complexity increasing, if complexity increases, speed decreases. I'm saying like if complexity increases, speed decreases. But this also we can see one query, right? Okay. Select sum of amount from sales one. Okay. Okay. Now select average amount. Select average amount from sales one. Standard deviation of amount, right? Standard deviation of amount. Sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one. So here, which query? Think that sales one. Think that you got some 1 lakh records. So total amount from sales one, average amount, standard deviation, right? Okay. Here, which query executes faster among these three? Obviously the first query, right? Because average amount is a two-step process. First, we need to calculate sum to be calculated, next average to be calculated. Standard deviation, lot of internal processing required, right? So from query to query, right? As complexity increasing, speed decreasing, right? And the major drawback with the databases, right? Now observe this. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. Okay, for example, let us take one. Databases can handle only structured, but for example, if I want to take, for example, observe this. I want to take reviews for a particular movie, right? For example, if you want to take a reviews, the table name is reviews. So here like user and review. User 1, user 2, user 3, user 4. In this way, 100 users, right? Giving review like 0, 1, 1, 0, 0, 1, right? In this way, they give that feedback, right? Okay. Now, if the movie is good, say they are saying 1. If the movie is bad, saying 0, right? Using SQL or using this database, right? Using this SQL, can you write an SQL query to count the number of ones and zeros here? How many people saying good, how many saying bad, right? Can I count aggregation, right? The number, okay, how many people saying good, how many saying bad. Select review wise I want to count, review wise count I want from reviews table, group by review. A review wise count I want from the reviews, group by review, right? Group by review. Okay. Okay, see, observe this output, like reviews like 1 and 0, right? Observe this, for 1 you got the count 90, for 0 you got 10. So 90 people saying the movie good, 10 people saying the movie bad. So for this kind of structured nature, right? Okay, you can write that, you can perform this SQL. But generally, like reviews won't be given in zeros and ones. The first person saying like movie is good. Second person saying the movie is not good. So if they're giving in their own text format, right? Now can you write an SQL query to count the number of goods and not goods, right? Is it possible to write an SQL query to count the number of good and not good, right? Not possible, right? Even if you say like using keyword count, it gives wrong computation, as even not good is having good within it. So wrong computation, right? Yes. Okay. So databases can handle only structured data, but now see this advantages of Hadoop. Okay. Hadoop advantages, right? Hadoop advantages. Unlimited data storage. Unlimited data storage. Very high speed processing. It is an open source, no licensing required. Unlimited data storage, very high speed processing, open source, no licensing required, right? Okay. Can handle all varieties of data. Can handle all varieties of data. Okay. Unlimited data, there's no limit on what is the data. Like if you talk unlimited data storage because of a feature horizontally unlimited scalability. In Hadoop, we have got a feature called as horizontally unlimited scalability. Unlimited scalability, right? Fine. What is this horizontally unlimited scalability? Means you need to understand something about this Hadoop architecture, right? Just I'll give overview of it. Based on that, you can just enumerate the advantages. Hadoop follows master and slave architecture. Hadoop follows single master and multiple slaves, right? Master and slave architecture. It won't follow client server architecture. So if you talk about this, we call it as like master node, and this we call it as like slave nodes and data nodes. Slave nodes or data nodes. Master node, and here we can say like name node. So here in Hadoop, divide the name data nodes because data stored by the slaves, data processed by the slaves. So data storage is by the slaves, data processing by the slaves. Okay. In Hadoop, if we talk, data is stored in the form of files. The file is subdivided in, okay, think that f1.t, each system, like each slave capacity, 1 TB, 1 TB. Okay. A file of size, for example, 3 TB, right? It cannot fit into any of the slave system, right, of size 1 TB, 1 TB. So in Hadoop, a file is divided into smaller parts. Smaller parts, we call them as blocks. The blocks are distributed across the slave machines. The data is distributed across the slave machines, right? So here two advantages you can observe, right? If data is distributed across the slaves, parallel processing can happen. Processing the data parallelly. Distributed storage and parallel processing. You're going to see like parallel processing and distributed storage. So here, if tomorrow, for example, today you are running a business with some 10 slaves, right? Your data is increased, your customers are increased, right? Your branches also increased. So with that, if data increased by 100 times, customer increased by 1000 times, you cannot go with the same number of slaves, right? We are going to increase the number of slaves horizontally. Horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Horizontally unlimited number of slaves can be added, right? Okay. That is what, because of this horizontally unlimited scalability. Okay. Very high speed processing. Very high speed processing means as compared with the other technologies, Hadoop has proven in the market. If I want to justify this very high speed processing, right? Yahoo has conducted a test. Yahoo has conducted a test to check the speed of the various databases in the market. It has taken a table of 100 TB consisting of 1024 columns. Okay, the task is sorting based on 16 columns. Sorting based on 16 columns. Okay. Yahoo has conducted a test to check to test. Okay, it has taken a table of 100 TB of 1024 columns, sorting based on 16 columns, right? Sorting based on 16 columns. So what is the time taken? Time taken by the various databases, right? Time taken by the various databases. For example, first Oracle has taken nearly 3.5 days to process it. MySQL like 6 days, right? It has taken like 6 days. Teradata, right? A specialized database used for data warehouse purpose. It has just taken 4.5 hours, right, to process it. Netija, another specialized database. It has just taken 3 hours to process it, right? 3 hours, right? Finally, Hadoop. Finally, like Hadoop, right? It has just taken 3.4 minutes to process it, right? That is what the speed of Hadoop. Because of this parallel processing, data is getting distributed. Very high speed you are going to see for Hadoop. The latest version of Hadoop has just taken 1.2 minutes, right? 1.2 minutes. Okay. That is Hadoop is proven processing point of view, storage point of view also by storing unlimited data. It has got horizontally unlimited scalability, right? Okay. So many projects are getting migrated to Hadoop environment, mainly like ETL kinds of projects. So they are migrating to Hadoop environment, and you can just check that Hadoop and Spark jobs, right? You can see a lot of jobs for Hadoop and Spark. So what I'm going to discuss as part of this course, right? Let me just demonstrate that. Mostly like I'll be taking like 100 hours, right? 50 hours for this Hadoop and 50 for Spark. Nearly like it takes for 2.5 months. The course will be for 2.5 months. Okay. Hadoop and Spark with Scala, right? So what is big data? Okay. What is big data? What is Hadoop need for Hadoop? Sources, types, challenges, HDFS, Hadoop distributed file system, MapReduce. So there are some components which are got deprecated, which are not much used. They're outdated, right? Some. So here Hive is scoop for import and export operations from databases to Hadoop, Hadoop to database, import and export operations. Yarn, big. Now they are not much used, but okay, I'll be just demonstrating about those big and NoSQL databases, okay, HBase and Spark with Scala, Spark Scala programming. Next, like Scala functions, Scala collections, transformations over Scala function, all this, right? Next, Spark core. Introduction to the Spark core programming, like the RTD's concept. First, before that, I'll be comparing the different technologies with HANA, with Edge, with MapReduce, with Flink, right? How this Hadoop, right? RTD computations, RTD actions, transformations, filters, persistence features, and here like coming back to this persist memory under Spark core computing, fault tolerance mechanism, different ways of creating RTD. Next, groupings and aggregations. Various actions and transformations, built-in actions and transformations in Spark. So one by one, each in brief with multiple examples, like Spark SQL, all these things, right? And deployment, local mode, cluster mode, standalone, right? Plus Spark application stages and tasks, driver and executor, and how to submit the Spark jobs, right? Creating job using Eclipse IDE, I'm going to show you, IntelliJ IDE, I'm going to show you, and I'm going to show you in build tools like SBT, Maven, right? Okay, and Spark and Cassandra also, I'm going to provide you the knowledge, right? So these are that in brief. For Spark, I'm taking like 50 to 60, 50 to 55 hours, right? And for Hadoop also like nearly like 40 to 50 hours for this. So clear notes will be provided. Every session is a video recorded one, right? Even if you're missing 1 or 2 days, right? You can just check this videos and attend the next session for the better understanding, right? So even tomorrow also people can attend the session more on this, right? To see more on this Hadoop, right? How exactly like the data storage, data processing happens, and why only data, why can't the databases cannot store unlimited data? Now, okay, if you've got any queries, right, you can go with your queries, right? If you've got any queries tomorrow also, like same time using same link, you people can attend the session, right, to see more on this. Hope you understood what is big data, why, how to drawbacks of databases, right? Mm. Yeah, you will be shared the syllabus copy, right? You will be given the syllabus copy, right? So everything in brief, everything in depth. So I was saying like 100 hours for this will be taken, okay, with many examples and notes, right? Spark also nearly 50 to 60 hours I'll be spending on Spark. My concentration will be more on this Spark. Hive. Hive also nearly like for 20 days I'll be discussing on this Hive, right? Fine. It's a kind of data warehouse kind of an environment within this, okay, Hadoop framework. Yeah. Any other queries, right? Any other queries you have got, right? Yeah, that syllabus copy will be forwarded to you, all right? You can just go through it. Yeah, providing material, yes, material, clear notes will be provided topic wise, right? Topic wise, I'm going to provide you that, right? And also like installations, don't worry about the installation, right? Clearly, I'll be just providing you that software, and also I'll be demonstrating about those things, right? About the softwares. Yes, clear. See, this practical notes will be different, right? So what all the practicals I'm doing, right? I'll be just copying and I'll be providing some comments to it and I'll be forwarding. It's nothing theoretical, right? Everything practical, and wherever for all that statements, I'll be providing comment and I'll be forwarding, right? So config, see here, systems, any system can support that Hadoop, right? Any system supports this Hadoop, but only the speed is going to differ. If you have got some old configuration, less configuration, RAM capacity, other things, your system that is going to go little slow. But if you have got a good configuration, you'll be getting that. You have got good speed, you'll be getting the results immediately, right? Fine. Yeah, one more question asked by Mike. One more, this course will be there, right? I mean last time. This means already recently a batch got started, right? So at 5 o'clock a batch is going on, started already, it's going on. Just 1 week back it was started. Yeah, the query asked, right? Some more queries asked, and programming along with this like Python. So what are the required things, prerequisites, like basic Linux commands? I'll be just see the prerequisites, like you need to have that knowledge of basics of Linux commands, basic Linux commands, basic SQL. These things are required, right? And the scala programming, everything I'm going to brief you, right? So just you'll be understanding all the things what we are discussing. The prerequisites, what are required. First, I will discuss that and we'll be going with the topics, right? So the total things will be like step by step. Step by step, we'll be discussing the things. You can just attend the sessions, right? Tomorrow and after tomorrow to see more on this big data, right? Yeah, any more queries? Yeah. Okay, fine. Okay, if I'm done with your queries, if there are no other queries, then we will just continue it in tomorrow session, right? If you have got any more queries, you can ask me in the tomorrow session more on this big data, right? Hadoop and Spark. So how exactly the data storage, data processing, and the other things, right? Why only Hadoop can perform those, why not the other technologies, right? Fine. More on this. Okay, you can attend the sessions tomorrow, day after tomorrow to see more on this, right? Follow the same link and same time at 6 o'clock. Fine. Okay, basics concepts of Java is required, but there is a component called like a map reduce, right? Which is not much used in the industry now, where we are going with Spark instead of map reduce, right? For that map reduce component only Java was much used, but now that map reduce has got outdated, so we are going with Spark for it. So, but I'll just be giving some knowledge on this. I'm going to show you like some examples on it. Going to show you that concepts of map reduce, right? Yeah. So only like course duration will be like 2.5 months, right? 2.5 months to 3 months max. Like we'll be talking about 50 hours on Hadoop and 50 hours on Spark. So 1.5 month for both, right? So some bigger sessions will be planned on Saturdays if possible, but if you are going out of days, right? So not Saturdays and Sundays, Monday to Friday only, but at the ending of that course, right? we need to spend time on that, right? So basic concepts of oops, right? That's enough. Okay, fine. That too for one or two components will be seen, but most of that important component, even for Spark, anyhow we go with like Scala language, right? Okay, fine. Okay, you can just check that training levels also by attending the next 2 or 3 days, right? We'll see more on this. Fine. Okay, I'm stopping here. We will continue tomorrow, and thank you for your time, right? Thank you.